Hello and welcome to today's lesson. Today we're going to look at some trig examples. And I've already sketched out a little drawing here where we've got a tree and we're trying to determine the height of this tree. We've got some other information. We got a person standing 20 meters away from the tree and the height of this person is 1.7 meters. It also tells us the angle of elevation is 35 degrees. So what I'm now going to do is try to draw some information into the picture here and see how we can determine the height of this tree. So let me just draw in a few things here. For one thing, I'm going to take where the person's looking from and put a little line that's parallel to this line at the bottom, to the ground. And then we're also going to draw in a line of sight to the top of the tree. Okay, so I think we're just about ready to get started here. This would be assumed to be a right angle. Now this angle here is what we call the angle of elevation. It's from the horizontal looking upwards, in this case to the top of a tree. So that's the 35-degree angle. And if this length down here is 20 meters, then I know so is this side here on my triangle. So I look at this and I go, well, how can I get the height of the tree? Well, I can certainly determine this length here. Let's call it x, because that's a side in my triangle, my right triangle, and I know this side here and I know the angle. And then what I'm going to do is I'm going to add to it the height of the person, which is 1.7, and together that should be the complete height of the tree. So let's see if we can get some trig going here. Relative to this angle, and I'm just going to change colors here. Let's go with blue. This would be across from the 35 degrees, so that's opposite. And that makes this guy over here adjacent, because across from the right angle is the hypotenuse. Now I got to figure out which trig function is going to help me find out the opposite. And I know the adjacent. So I'm going to think of SOHCAHTOA here. I'm looking for the one that uses opposite and adjacent. There it is. It's going to be tangent. So let's just change color back to black. So my trig equation is going to look like this. Tangent of 35 degrees equals the opposite, which is x, divided by the adjacent side, which is 20. And I'm going to make this a fraction. And now to get x, all I got to do is cross multiply 20 times tan of 35. I don't even need to divide by 1. And so if I do that on my calculator, I found that I actually got 14.00. Now don't forget, to get the height of the tree, I have to add 1.7. So it's going to be 14 plus 1.7. So we think the height of the tree is 15.7 meters. That's my first example wrapped up. All right, and I'm just going to look at one more example, but let's clear this off. Okay, so let's see if I can get my drawing here. We just got to move it in here. All right, so there's my drawing. What we have here are two buildings, and we know the distance between the buildings is 100 meters. And I'm told the angle of elevation. Now what it is, there's a person looking out from the window here, right at the top of this building. And the angle of elevation to the top of the other building is 10 degrees. The angle of depression, which means from the horizontal looking to the bottom of the other building, is 15. I'm going to draw that in here. I'm just going to change to blue, I think. So let's draw in our triangles. Oops, let me undo that and use the line draw feature. It'll look a lot neater. Okay, so here's my angle of elevation to the top of the other building. Something like that, and we're told that this is 10 degrees. So that's 10 degrees, and we would assume that to be a right angle. And now I'm going to draw in, if the person's looking to the bottom of the building, the angle of depression. Okay, so again, assuming that to be a right angle. And the angle of depression here is 15 degrees. So how am I going to solve for the height of this building? That's what we're after here. So how high is this second building? Well, if this is 100 meters down here, I'm just going to parallel that up to here. Then that side is 100. And if I look at my top triangle, I could certainly get this length here. Just a minute, I'm going to make that thicker. Let's say I call that Q. I can certainly figure out what Q is using a little bit of trigonometry. But if I look at the bottom triangle, I can figure out this side over here. Let's call that P, using trigonometry. And when I add Q and P together, well, I have solved for the height of the building. So let's do that. So the top one here, and I'm just going to cut to the chase. This is opposite. Q is opposite 10 degrees, and the 100 meters here is adjacent. So I'm going to use tangent. So tangent of 10 degrees is equal to Q divided by the adjacent side of 100. So then I would cross multiply, so Q would equal 100 times tangent of 10. And I found that to be 17.63. And then if I use my bottom triangle, I am going to also use tangent, but it's tangent of 15 degrees, which equals the opposite side, which is P, divided by the adjacent side, which is 100. And again, make that a fraction. So I can just cross multiply. So P equals 100 times tangent of 15 degrees. And I got that to be 26.79. And so the height of the building, the taller building that is equal to 17.63 plus 26.79, which calculates out to 44.42 meters. And there we have it, the height of the second taller building. And with that, I am going to stop. So we'll catch you later.